Hi everyone, welcome to another Learning at Lambert Labs session. Today's presenter is Tom, so I'll hand over to Tom.
Thank you, Tom. So today I will be talking about the Shellshock vulnerability, and I'll be demonstrating that through Django. So first, what is the Shellshock vulnerability? It's a critical exploit affecting Bash versions up to version 4.3. And the common vulnerability scoring system gave it a score of 9.8 out of 10. So that's pretty severe. And it's such a high score because the vulnerability allows you to run pretty much arbitrary code on the target machine. This vulnerability was first reported on the 12th of September 2014 by Stefan Chazelas and was patched and resolved 15 days later. But the interesting thing is that the vulnerability had been present in Bash since version 1.03, which was released way back in 1989. So it took 25 years for somebody to notice this vulnerability. So in order to understand the exploit, we sort of need to start from the beginning and work up step by step. So what is Bash exactly? So Bash is a command interpreter or terminal present on most Unix systems. So that includes like Linux, BSD, and Mac OS. It can function as a programming language too. So if you see these shell files, if you look inside them, then you'll see it looks kind of like a programming, like a script written in a programming language, but it's mainly a command interpreter. And the Bash program typically lives at bin bash. It can be used interactively, like in a terminal, but can be used non-interactively as well. And this is a non-interactive example where we invoke the Bash program, we pass in the C option, and we pass in a string. And this string echo is the equivalent of print in Bash. So this will print hello. Okay, so let's talk about variables and functions in Bash. These are some of the kind of programming-like features of Bash. So you have Bash variables, which we should be all familiar with. So var equals ABC. So this creates a variable called var with the value string ABC. But we can also have functions in Bash. Functions allow us to reuse code blocks as they do in pretty much any programming language. So this is a typical function definition. We type in the name of the function first, then we have these braces, and then brackets, I should say, and then inside the curly braces we add in the code. So in this case, we've defined the function func, and this function, if we type in the function name, it will print out hello. Note that Bash functions use positional parameters only. So in this case here, I've replaced hello with a $1, and $1 references the first positional parameter. And the way this will work was if we define a function like this, then if we then type in func hello, then it will print hello. But if we type in func bye-bye, it will print bye-bye because it's first positional parameter. So the point is that you would never add in anything inside the brackets here. The brackets are always empty. It just takes in whatever you, as arguments, it takes in whatever you put in after the function name. Okay, so those were variables and functions. Now we need to also understand more about environment variables. So environment variables are a set of variables stored in processor's memory that can get passed on to child processes. And to view the environment variables in Bash, you can run the env command, and technically env lists the environment variables of a child process. But for our purposes, it's pretty much the same. We can just say env prints the environment variables. To create a new environment variable in Bash, we use the export command like this. This will create an environment variable called var. We can then use this variable in a child Bash process. So the way it kind of looks is that you export var as an environment variable, and then a child's bash process will automatically import all the environment variables. So you can then, in the child bash process, type in echo $var, and that will print the value of var in the child's process. We, of course, are very familiar with the export command because we use it in bash RC, so you can pre-populate our shell with predefined variables. Okay, so we've talked about variables and we've talked about variables and functions. We've talked about environment variables. So the question is, well, do we have something called environment functions? Do they exist? And the answer, quite surprisingly, is yes. So functions can also be exported in bash. So this is a this is a function definition that we've seen in a few slides before. It just prints hello, and we can export this function and essentially create an environment function out of it. So you would type in export -f func. So unlike a previous case where we just put in export, now we have to add in this f option. And once we do that, if we open up a child's process, we just type in the function name, and it works as before. It's as if we've imported the function from the parent process. So that's how environment functions work. Now, what happens behind the scenes when you type in this command, export -f func? So behind the scenes, bash first creates an environment variable. An environment variable looks like this. So it has the function name, and then the value is like a stringified version of the function definition. So you see, it's very similar. It's just they've added an equal sign kind of right here, and they've put the rest in quotes. So it creates the environment variable func. Then when the child bash process is created, it scans through all environment variables and sets the environment variables as appropriate. So that's the kind of normal behavior of how environment variables are imported. But if the value of the environment variable begins with this substring, it replaces the equal sign with a space. It removes the string quotes as well and executes. So this is a kind of more like visual example. So this would be the first step of export -f. It creates this where it creates this environment variable func equals function definition. And if when the child bash process sees this variable, it removes the equal sign, removes the quotes, and it executes this line. And this is exactly where the vulnerability lies, because first of all, notice that we don't have, if we want to export a function, we don't have to type in the this command here. We can just define this variable kind of from the outset, right? And so if we can define a variable like this, and the child bash process will execute this, what is stopping us from inserting an evil command after the function definition? Because won't that evil command also get executed? And turns out that the answer is yes, that bash doesn't do any kind of checks, it just executes everything. And so if we can control any environment variable, and if we have a child bash process open, then we can have, then that allows us to exploit Shellshock, basically. So this is the kind of main equation you should remember. We just need to update any environment variable, and we need a child bash process to be opened, and then we can run any commands we want on the target machine. Okay, so before I demonstrate that, just a few words on the subprocess module in Python. So you may have seen a line like this before. What the subprocess module and what this line in particular does is it essentially it makes a call to the system to execute a program. It creates a subprocess and it executes a program on the OS essentially. This line in particular, it will run echo hello on the shell. And basically this line gets translated to this line, and this line gets translated to this line. So subprocess.run echo hello with shell equals true, it translates to sh-c echo hello. So you see this this function here has already created a child shell process. Okay, now what is sh exactly? Because it's not bash always. It turns out that sh is a symbolic link to the default non-interactive shell on the system. So on Ubuntu and Debian, that default shell is something called dash, which is just a stripped down version of bash. But most importantly, it's not bash itself, it's dash. On Androids, the default shell is mksh, but on Red Hat Enterprise Linux, CentOS, and Fedora, the default shell is bash. So these distributions are particularly vulnerable to the Shellshock exploit. Although that doesn't mean that Ubuntu and Debian aren't vulnerable as well. If any process on there creates a bash child process for any reason whatsoever, then they are also exploitable. Okay, so that's the demo, and I just want to kind of say, keep in mind this equation. We just need, as long as we can update any environment variable and a child bash process created, we can use Shellshock just by kind of setting the environment variable to have our evil command. So let's see this in action. So here I have a Docker container running, and this Docker container is just like a minimal Django application. And you can see in here, actually, if I refresh the page, it's running right now. So this is like the demo Django. This is like the first page you see when you install Django. That's like the default front page. But I've made a few small changes to this app, and I'll go through them right now. So the first change is I've added a couple pieces of middleware. So in Django, middleware it allows you to alter the incoming request or the outgoing request. It sort of sits in the middle between you, the client, and the app itself. You can also think of it as like layers of an onion around the core app. Every request and every response will hit some middleware. So I've added two pieces of middleware. So the outer layer of middleware is something called set user agent. And what I do is I look at the request and I grab the user agent from the request headers and I set it as an environment variable. And that's all I do. For every request that's coming in, I set the user agent as an environment variable called user agent. Now, two things about this. First of all, why on earth would I be doing this? And it might seem quite contrived and strange, but I will come back to this. There is a precedent for this. But for now, just think, yeah, for some reason, a developer wants to do this, right? And now the second thing I should mention about this line is what is the user agent exactly? So agent means agent is the thing that the user used to make the request, essentially. So a browser is an agent, right? And if I go to, and the user agent is a request header for every request that the user does. So if I go and inspect this page and I make a request, let's just click reload here. You can see on my request, I appreciate this might be quite small, I'll just copy the user agent. So there is a header, a request header here called user agent, and I just copied it and I pasted it here. And so this is what a user agent typically looks like. So it just lists my browser, my OS as well, that browser version and so on. But what a developer who writes this line, what they might not realize is that the user agent can be made up completely. It's completely, the user can control the user agent completely. And so in effect, what this line does is it's created an environment variable which can be completely controlled by the user. So this middleware here meets our first half of the equation. The user can update this environment variable user agent. Okay, and then there's a second piece of middleware, which is the request log middleware. And all this middleware does, it does something completely different. It looks at the request path and it logs it to a file called request.log. So it actually, what it does is it prints the date and then it prints requests to request.path. And this is like a simple one-line kind of logging solution, I guess you can say. Yeah, as you mentioned, subprocess.run, this will invoke the sh process. So it will create a child sh process, as we discussed on the previous slide. But on the Ubuntu, of course, which I'm running now, the child process is not bash, it's dash. So what I've done, this is the final thing I've changed about the default Django app, is in the Docker file, I've added a line which creates a symbolic link between sh and an unpatched version of bash. This is bash version 4.3 before the Shellshock exploit was patched. So in effect, this middleware here, it will create the child bash process, and that bash process being vulnerable to Shellshock. So that second piece of middleware, it completes this equation basically. And now we have this complete equation, and we can now run the Shellshock exploit. And the way we do it is we would create our user agent like this. So we create user agent which looks like this. We just put in a kind of dummy function definition, and after that function definition, we can put in an evil command, and that command will run on the system essentially. So let's see that. Of course, in the browser, I can't really control the user agent easily, so I need to use curl. So curl just is like a browser in the terminal essentially. So if I type in curl here, it's returned this page here. It's returned this page in return the HTML contents of that page basically. I'm just going to run it again, but I'm going to add dev null at the end. This just kind of hides the output, which is useful for us. And now to edit the user agent, I just passed in this flag, -a, and -a allows me to set the user agent. So let's see, I'm going to type in dummy function definition. That just echo nothing. And then after that, I can put in anything I want. So let's type in echo ha ha ha. Run this. As you can see, it's printed out ha 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 in the standard output. Okay, so that's that just demonstrates that the Shellshock that we've used the exploit. I can also do, of course, any other command like ls, and that lists the files, and I can also even maybe print the contents of this file, or even the Docker file. So you get the idea. I mean, we can do many things. But we've basically, we can now, just using curl, we have the power to run any command on Django, or I should say on the container. Now, this by itself is not very useful because an attacker obviously they can't see this, right? This is all on the app. They don't have access to these logs. The whole point really is to kind of see inside, but we can't see inside. We're just running commands, and actually, someone watching this will think, "Oh, this looks strange. Why is this log suddenly printing out the list of files?" So he needs to be a bit more clever about this. So what I suggest is we open up something called a reverse shell. So what is a reverse shell? So usually when you create a normal shell, usually the client will initiate a request to a server, and the server will respond back, and then the client kind of ends up with a shell to the server, or a target, some target, could be anything. That's how a normal shell works. But a reverse shell, in a reverse shell, it's the server which initiates the connection. But still, you still want the client to actually have the shell, to be in control of the shell. So it's a bit of a kind of funny alteration on how a shell is initiated. And the reason why the reverse shell is is used by attackers is because firewalls are typically restrictive of incoming requests, but they aren't restrictive of outgoing requests. And so using a reverse shell, we can very easily actually just, as long as we can run any command on the server, we can create a reverse shell, and that allows us to run any commands easily on the server. So how do you open a reverse shell? So on the targets, we run this command. Now this is a kind of bit of a mouthful, so I'm going to break it down. So there are three parts to this command. So the first part creates, it starts bash in interactive mode, but this can be any shell. This we're just using bash in this case, but it can be any shell. The second part of this command, it looks a bit kind of unfamiliar, but what it basically does is it redirects a standard out and standard error to a TCP stream, which essentially means it redirects standard out and standard error to across the network, essentially. It redirects it to IP address 172.17.0.1. And it's important to understand that in Docker, by default, when you create a container, according to the container, the host has the IP address 172.17.0.1. The first container has IP address ending in 2, the second container has IP address ending in 3, and so on. This is how, by default, the network works in Docker. So what I want to do is I want to initiate a reverse shell from the container onto the server, or onto the host, onto the Docker host. And so I need to pass in the IP address of the Docker host. And that will be this first request, which will go to the host here. This is the container here. And then the port can be any open port. We're just going to use 8001. In real life, this would be my public IP address and a port, but because we're using Docker, we need to use sort of Docker IP addresses. So this part redirects SDR and SDR to TCP stream, and then this final part, it actually what it does is it opens standard out, which is represented by this here. It opens standard out for reading. So in other words, the input comes from the TCP stream. Let's see this in action. So I'm going to copy this. Is going to be my evil command. I'm going to copy this and use it in my spoofed user agent. And before I run this, I need to open up port 8001 for listening. And the way to do it is using netcat. That's listening up now. And now if I run this, you can see I have a shell down here. And I have a shell into the container, and I've used nothing but curl for that. Interestingly, this is a root shell. The reason it's a root shell is because we're actually running we're running Django in the container with the root user, and so because this shell is the shell basically inherits the permissions from Django. I know I can do anything I want in this shell, ls. I can even, of course, go into the Django shell, and I can say things, and yeah, I can see anything I want basically. Okay, so I think I will leave it there, just looking at the time. I did have some more slides, which I think I'll post on GitHub so people can look at that. But yeah, I think we'll leave it there. So does anyone have any questions?
I've got a question, Tom. Firstly, thanks for the talk. Very interesting. I'm just interested at a more high level in the kind of the aftermath, if you like. I think you said that this bug was discovered, I think it was 2014, you said. And it was patched within 15 days. I mean, am I right to assume that presumably people hadn't been exploiting, hackers hadn't been exploiting this bug for the full 25 years, I think you mentioned, but it had been in production effectively? Because I feel like we might have known about it if they had been.
Well, who knows? That's the $1 million question.
Yeah.
It might well have been exploited. But yeah, I mean, 2014, which is, I think I was quite careful to say first reported on 12th of September 2014, but who knows if it was actually used before that. But yeah, but it was patched. Yeah, it took 15 days to patch. Fully. Yeah.
Sure, thanks.
Sounds like there are no more questions. So just say thanks, Tom. That was really interesting. And thank you, everyone.